So in this question, we've got a left-hand versus right-hand question, and we've got to prove that they're equal. Okay, we've got two brackets to expand. So we get 4m squared plus 1. Now the underneaths, we get a 2m and another 2m, which is 4m minus. Now I'm going to put a bracket for these next terms because I've got enough problems multiplying the bracket out without including the minus out the front at the moment. This is going to be 4n squared plus 1. Negative 2n and another negative 2n is minus 4n. And now let's multiply the right-hand side out. The thing you mustn't do is start moving stuff across from one side to the other. Multiplying this bracket by m, I get m squared minus mn plus m. Now multiplying this bracket by positive n, so we get another mn minus n squared plus n. So, taking this bracket away, we've got 4m squared plus 1 plus 4m minus 4n squared minus 1 plus 4n. And on this side, simplifying again, we've got m squared. The mn terms disappear, plus m minus n squared plus n. Now on the left-hand side, plus 1 and negative 1 disappear, and I can take a common factor of 4 out of this. So this is 4m squared plus m minus n squared plus n. And that's equal to, copy and paste this, and there's your answer to part A. I'm coming up here to answer part B. Sophia says the result of part A shows that the difference of the squares of any two odd numbers must be a multiple of 4. Is she correct? Well, yes, she is. 2m plus 1 is an odd number. 2n plus 1 is another odd number. And we've squared them, and we've taken the difference. So that's the reasoning you should include to gain the marks for part B.